Uh, I will make sure that I will not take more than 40 to 50 minutes of your time. Okay. By 7 o'clock, we want to end the session. I think 1 hour is the maximum I can ask you guys to spare your time for us. So with that in mind, I welcome you all once again to this session. The course content, we will start with introducing you to the concept of human factor engineering. And we will have a brief discussion on how workplaces are designed. I want to look at a few case studies with you guys. And these things are so subtle, you may not have actually realized most of the impact of human factor engineering here. So, however, some of those aspects we will discuss right now. Then we'll bring in the anthropometric measurements, a concept often forgotten about in the field of human factor engineering, and we will explain how significant that is in implementing it, and the correlation analysis between this ergonomics and other occupational issues, and briefly talking about certain methods of improving this workplace ergonomics. Now, these topics will be intermingled and will be going throughout the session, right? So please bear with me, right? All the information that I have here is actually sourced from reputed scholarly articles. If there is any contention too, please directly let me know at the end of the session. Okay. So human factor engineering, right? We have been saying this word so many times right now. So what is human factor engineering? Also called as human factors and ergonomics that is there. It is the application of the psychological and physiological principles to design and engineering of various systems, processes, products. It is an interdisciplinary issue at the end of the day. A lot of factors are there that is influencing this entire concept of human factor engineering. For example, you have cognitive factors that is present there, physical factors that is present, and also the organizational factors that is present, right? For example, like a perception of an individual, right? Not everybody has the same perception, right? For example, if I were to ask you what's the color of a zebra, half of you will say it is black with white stripes, other half will say it is white with black stripes, right? So perception varies from person to person. Your motor responses are not the same, your memory, your reasoning. Same thing, anatomy is not the same. We'll talk about this in anthropometrics in detail. Certain factors are there. For example, not everybody's having the same height, not the same weight, not the same girth, right? Your physiology is different, male, female, right? And biomechanics, how well does your body move, as a factor there. Then your interactions between different levels, the level of communication that is needed, the teamwork required, and how well do somebody participate, the environment in which they are doing the activities. These are all factors that is influencing this human factor engineering, right? At the end of the day, the primary goal of human factor engineering is to reduce human error and to facilitate a situation where you are increasing your productivity and system availability, and at the end of the day, obviously enhancing your safety, health, and comfort with a specific focus on the interaction between human and equipment, right? Now, yes, it is an interdisciplinary field. Numerous disciplines come together. You have your psychology, sociology, engineering, biomechanics, industrial design that is present there, physiology is there, anthropometry, interaction design, visual design, user experiences, user interface design. All of these are coming together. And what you need to understand is when we're looking at HFE, it is not just something you're just seeing and you're just thinking, okay, this should be better. You do a lot of research on it, right? A lot of analysis actually goes through it in studying and sharing learning on the design of equipment, devices, processes that fit the human body and its cognitive abilities. The two terms, the human factor and ergonomics, are essentially synonymous as to their referent meaning in current culture. So the depth of human factor engineering. So number one factor is obviously it's an interdisciplinary approach, right? Integrating all of this into a holistic understanding. Plus, there is the systems thinking that is present. It considers the environment, the tools in use, the culture where we are implementing it, social factors for optimized interactions. And remember, it is all about user-centered designs too, right? So we need to produce for the mass, but while still catering to the needs of the individual, right? So involves the end user throughout, ensuring intuitive and effective solutions at the end of the day. And error prevention is a big factor there, right? We don't want the same kind of problems repeating again and again. So if we are having difficulty with the operation of a machine due to certain factors, HFE comes in. We implement it so that the problem is actually solved. And most importantly, adaptability. We know that nothing is perfect everywhere. Not every office is the same. Not every construction site is the same, right? And obviously, there are ethical consideration, prioritizing the ethics, inclusivity, right? We need to understand we are all equal, but we are all not same, right? So we need to actually have those ethical conundrums thought about, ensuring that everybody is having their inclusivity catered for, and continuous improvement, right? Nothing stagnates. We keep moving forward. Now, what is the impact of HFE on safety? So many industries, right, rely on human factor engineering. For example, aviation, right? In an aircraft, from the cockpit to the passenger seating area, so much of human factor engineering, ergonomics take factor, right? Cockpit design, control interfaces, procedure development to reduce pilot error, all about human factor engineering. Healthcare facilities, even medical devices, for example, surgeons, right? The tools the surgeons use over the years have been more streamlined and more customized to go with the curvature of the hands of the person, right? To make it easier to actually cut, to stitch, etc. Manufacturing industry, uh, vital role in designing ergonomic workstations, tools, equipments, etc. Transportation, for example, not just aviation, we're talking about, like, let's say, logistics, truck transport and such, right? Integration into vehicle designing, traffic management systems, driver interfaces to reduce accidents, all important here. So the question is, why should we care about these things? This is something that you may have to actually convince of the non-safety professionals, because at the end of the day, they have the attitude, well, as long as it isn't broke, why fix it? Now, to make them understand the factor, right? See, according to obviously ILO, we all know International Labour Organization, that is there. Occupational Safety and Health Recommendation 1981 of 164, number 164. Section 4, Article 10 actually does require that the employers make sure that the workplaces are as safe as possible, without risk to health as is reasonably practical, and to undertake the studies and stay abreast of the scientific and technical knowledge necessary. Well, ergonomics is essentially the answer that we're looking at. Now, there are some interesting facts about this. How did it originate? See, HFE actually originated during the World War II, when military aircraft designs needed to accommodate pilots' physical and cognitive limitations for optimal. I'm not saying it didn't exist before. I'm saying this is when it actually came to the mainstream. Earlier, we used to think about ergonomics. We used to have human factors in thought, but human factor engineering developed into a branch of science during this period. Various other industries then picked up on it. NASA's Human Factor Division focuses on optimizing the design of spacecraft, spacesuits, mission control interfaces to ensure the safety and efficiency of astronauts during space missions. The concept of user-centered design, fundamental principle of HFE at the end of the day, has been utilized for developing end-user process and products all over the world in every industry. And in today's world, with digital interfaces becoming more and more prevalent, human factor engineering has actually taken a front seat role in actually implementing this. So, for example, let's say home appliances, right? Can you even think about the appliance that you have today without thinking about ergonomics? For example, let's say even your knife, without this, textured grip, it's gonna slip out of your hands, right? The way you have your kitchen aisle or kitchen stand set up, right? Smart devices, user-friendly interfaces that is going on with smartphones, tablets, wearable devices that is there, you know. Then furnitures and interior design. Can you say that your house is not ergonomically designed? Nope. Public spaces that is present there. So much of ergonomics and human factor engineering actually goes into it. Even into general health and wellnesses, medical devices, healthcare environments, fitness equipment, all are impacted by human factor engineering, right? aviation safety, vehicle ergonomics, traffic management systems, accessible transports, right? Dubai RTA, Dubai Civil Aviation Authority, all of them actually have entire teams dedicated towards these, right? For example, let's look at logistic industry, warehouse efficiency, ergonomics regarding equipments to reduce fatigue and increase productivity. A material handling system, user-friendly interface are utilized and equipments which are more comfortable to use. Supply chain resilience is somewhere HFE has made a huge impact. Enhancing by designing systems by adaptable to changing demands. Driver interfaces, where you have trucks traveling long distances, a lot of HFE actually comes into their play. Now, we cannot conduct any webinar in today's world without talking about AI. Now, AI has had a huge impact on HFE and vice versa, right? Artificial intelligence over the years have actually enhanced the data analysis capability, helping human factor engineering practitioners to extract insights and patterns related to human behavior and performance. Helps us in designing personalized design solutions, actually. And most importantly, I would say the predictive modeling that is actually derived with the help of artificial intelligence is quite helpful. They help in anticipating, human errors and identifying potential safety hazards at this present, enabling a proactive interventions and risk mitigation strategies. Then you have your automation and assistance, AI-driven automation and assistance systems augment human capabilities, reducing cognitive load and enhancing performance in complex tasks. And there is also the ethical consideration we should never forget about, right? AI introduces a new consideration there, such as transparency is there, accountability, fairness, etc., requiring careful integration. We cannot say that AI is the perfect solution, but it is not a very bad solution, you can say. Now, I would like to explain how this actually is applicable for certain things. So, first one, I want to give you a case study about Boeing 777, the 777 aircraft design that was there. See, the Boeing industry that was present in the late 1980s, when they were embarking on the journey to actually create a new long-range twin-engine aircraft to replace the 767 they had to take a lot of input in. But they made it a point to make sure they made a huge emphasis on human factor engineering. A lot of those aspects, for example, the cockpits of the Boeing 777, was meticulously designed with human factors in mind, actually. Avionics systems that is present there, ergonomic seating arrangements, improved visibility. The pilot in the cockpit from that position should have the ability to access everything, right? And because of the duration of the journey, however long it is, they have to make sure they don't have any fatigue, right? Because a fatigued pilot can be quite dangerous. For example, like this, look at the design that is there. Seems like an aircraft, a spacecraft, right? But no, this is an aircraft still within our atmosphere. But see how beautifully it is designed. And from his seated position, he is able to access each point. Whichever is the closest one, those are the ones he has to access the most. Further away are the ones he has to access the least. And even in the way which one correspond to what acts. For example, let us say we have emergency control. They all come in a particular direction. In the sequence, it has to be used, right? The displays will actually give you an exact indication of what to do, what not to do. So even the way the controllers are actually positioned, how it moves forward and backward, all part of human factor engineering. The automation, the interface designs that has been actually created there, right? And not to mention the training and support system. With this in mind, the Boeing actually created the simulators where they were able to use the same human factor engineering into those simulators to actually create an identical training interface, right? Where they learned just as well in the simulator as they would actually learn driving the actual aircraft without actually putting themselves in the actual danger, right? So this 777 entered service in 1995 with a reputation about reliability, safety, and ease of operation. Pilots praised the aircraft for its user friendliness, the cockpit design that is there, the advanced automation features, and the success of Boeing 777 that is present is demonstrated in incorporating the human factor principles. And time has told the tale. You all know how common 777 is nowadays, right? Let me put forward another case study for you. The NASA space shuttle design that is there. How did it work? They created an entire uh, department for it, right? They call them the anthropometry and the biomechanics facility. Do you guys know that this department, if they say that it is a no-go, right? It has a lot of weightage than the others, because what they do is they customize the aircrafts, the spacecrafts, based upon who flies it. Whether it's a tall astronaut or it's a shorter astronaut, whether it's wide, whether it's slim, it doesn't matter. Whatever the dimensions of the person or whatever the reach of the person is, based on that, it is designed. It's quite extensive actually, and here are some of the information I've actually taken. The sources are actually listed on screen actually. So this information were actually provided to us by NASA, and these were the analysis they did. They identified everything: the media sagittal plane, the coronal plane that was present there. They identified what the transverse plane. They looked at the dimensions that is present. Uh, how it actually, even the arch of the person's face, because how it fits, the spacesuits, it all were brought into play when this design was done. When the seating arrangement was being set up, they identified what is the range at the tip of the fingers, right? When it is bent, when it's grabbing something, when they have to bend their arms, every single range was actually analyzed. How much further can they actually bend back, right? It's quite intriguing. Now, HFE in office, the comfort we need. I think you guys are not going to be climbing in any space shuttles anytime soon. So, however, I think this should be more pertinent to you guys, right? You guys all know what are the problems when you're working in the office, right? Where's your fingers, where's your wrists, where's your eyes, your back, your neck. I don't think there is a single person here who would say that I sit at eight hours a day in front of a computer and have no problems at all, no matter how well the current your workplace might be designed, right? See, for example, the standing desk with the height adjustable features that is present. The traditional desk requires individuals to sit for extended periods, which can lead to health issues such as back pain, poor circulation, increased risk of chronic diseases. So, recognizing these negative effects of prolonged sitting, ergonomic experts and designers develop the standing desk. Actually, the one you see on the screen is a small example of it. There is no brand name attached. You can feel free to actually look for other brands on the web. Now, the key features: height adjustability, it's sturdy construction, so giving the same structural stability as any fixed desks. It's an ergonomic design, obviously adjustable to any person that is there, and easy to use. It's designed in such a way that there is no difficulty at all, right? User friendly. Plus, reduce sedentary behavior, right? Let us say you were typing something, you feel your back hurts. You just pick that table up, you stand up and you do it for a little while. Let the blood circulate a little bit. When you feel a little bit tired, again, push it down, sit back down. It improves your posture, allows for a little bit of movement that is there, increases your energy and productivity. Seated in front of a computer for a long period of time do put you to sleep, right? But this wouldn't have that problem. And improved health effects, right? So over the years, so many user testimonials have been dropped forward. Many users report experiencing immediate relief from back pain, stiffness after switching to a standing desk. Employees appreciate the flexibility and freedom to customize their workstation, and most importantly, the morale, their engagement have been improved. I highly recommend, and I humbly recommend that you guys actually have these implement your organization if you already have not. Okay. And this is just the first step, a gateway. Okay. Now, allow me to take this opportunity to talk about a few more aspects, right? So one of them is anthropometric measurement, a topic that cannot be forgotten when we're talking about human factor engineering. It's a discipline which involves the, you can say, what does it do? It helps you to study the body's limitations, the stretches, the lengths. Now, ergonomics, as you all know, is the study of interaction between the workers and their work, and is concerned with the design of the workplace, equipment, and methods with the needs and limitations of a human operator in mind, right? And what is anthropometry? It's a measurement of the physical attributes of a human being. For example, this is the top view of a person who is seated at a table. Now you can see there are two ranges that is there, a darker purple and a lighter blue outer rim. You can see. What is that? The one is the normal work area where you have your arms slightly bent, and the other is the reach area, the maximum work area where your arms can reach. If you look at the test that you're probably seated at right now, I think this is the basis of because of which it was designed to have the same size. So what happened is in ergonomics, anthropometry was used to become the basis of setting up a workstation, right? In the science of the anthropometrics, the measurement of the population's dimensions are obtained based on the population size, strength, capabilities, and differences. You need to understand anthropometrics varies from point to point. Not every country has the same anthropometrics. May I give you a simple example? Do you think the cars that is designed in different countries are all having the same level of sizes? For example, let's say your steering sizes, the seat sizes that is present, the amount of leg freedom that or leg space that is available there, right? In a country where the average height is 6 foot, the size of the cars will be entirely different from a country where the average height is maybe around, 5 foot 6 inches, right? So that difference is what anthropometrics actually measures. And this helps the various organizations as well as the nation's government to design policies and stipulate limitations on product designs, right? So how is it calculated actually? For example, with average height, right? For if we use something called a stadiometer, right? Hope you guys have seen something like this, right? The stadiometer on the screen. So you get a person to stand straight, right? With their their heads, the buttocks, and the legs straight. If unless they have a knock knee, if that situation, feet slightly apart so that there is no overlap, right? And there is a measurement taken twice, and an average is actually considered. Now, a large range of different age ranges and different parts of the country, different parts of the region is actually analyzed, and based on which they calculate what is considered to be the average height of a person in a place, right? For example, this is actually a calculation that is present from USA, right? Dimensions that is present there. What's the height of the individual, right? Varies. So what is a percentile wise? So you can see 5% is 167.5 centimeters. And as you can see, it keeps going upwards and upwards, right? While you can see the average is in the center, right? 174.6. Remember, when I say 95 percentile, I'm not saying that 95% of the people are 182.7. No, I am saying that it is the range. You can say the mode at which it is actually spread apart. Okay. So this is the top end, this is the bottom end. Think of it like a pH value, 7 being the normal and the 14 and the 0 on both sides, kind of like that. Another one that we have as part of your anthropometrics is body mass index. I think there is nobody here who doesn't know what BMI is, right? Calculation of BMI, I think everybody knows, right? Formula in metric system is weight by height squared, right? And you calculate it and you identify what is your body mass index. Now, let me talk about what is the correlation analysis between this ergonomics and other occupational health issues. For example, repetitive strain injuries, cumulative trauma disorders. I think some of you guys might have learned it another name, work-related upper limb disorders that is there, right? And associated trauma orders that is present, fall under the umbrella terms, right? They refer to several discrete conditions that can be associated with repetitive tasks, forceful exertions, vibrations, mechanical compressions, sustained or awkward positions, and repetitive eccentric contractions that is present. For example, you have various things like tendonitis, peritendinitis, epicondylitis, tenosynovitis, all examples of the same. You have your carpal tunnel syndrome, tennis elbow, etc. Yeah. Now, one of the most common reasons why ergonomics is ignored is that we often confuse the symptoms it causes with other conditions, right? For example, we tend to attribute neck and shoulder pain, headaches, and even eye strain to working too many hours. Tingling in the extremities to conditions like anxiety rather than the same posture. Muscular pain to maybe an axe injury. Okay, maybe I hit my hand somewhere. That's why I'm having a muscle pain. You know, see, over the years, as safety professionals, practitioners, we have learned, we have your four factors to consider: the load, the individual, the task, the environment. We shall never forget that in application too. For instance, guys, I think I'm also all I'm asking for is an introspection. We all know that we should not bend to pick something up, correct? But can you all, in with absolute certainty, say that you don't do it? Even today, I can say, let's say you dropped your keys right now on your way out from your office or your home. I'm pretty sure you bent to pick it up, right? There are very few people who would actually sit down to actually grab the load and get up. Meaning, we'll say, sir, it's not heavy enough to be qualified as manual handling. It doesn't matter whether it's heavy or not. The weight is not that matters at that moment. It's the action, because it turns into a habit. And once it turns into a habit, you do the same thing again and again, even when you have heavy loads to pick up, right? And you have your what's that, load limiters that is present there, right? You know for a fact you can carry it highest at the knuckle height, but a lot of people actually usually carry it at elbow height, or may carry two of them in their shoulders, up their shoulders, etc. Right? Now, not just you, even your, let's say you are from the construction industry, you guys know exactly what I'm talking about. A lot of workers do prefer having it carried on top of their heads. They believe it is actually better and does not affect their body more, which is so far from the truth. Actually, it does affect their body a lot. And the fact of the matter is, they don't realize it until it is too late. Right? No matter how well built their muscles are, your body's musculoskeletal structure is not designed for carrying load that way. You know, for example, like I said, in construction industry, the number of back injuries in the US construction was close to 50% higher than the average for all other US industries in the year 1999. Now, after what we have seen, these initial reports have not come down. It has just kept going up. Backaches and pains in the shoulders, neck, arms, and hands were the most common types of symptoms reported by construction workers in one study. Metal handling and incident accounts for 32% of the workers' compensation claims in construction and 25% of the cost of all claims. The average cost per claim is $9,240, which is a lot. Now, in construction industry, some of the common issues, for example, when it comes to awkward posture, when they have to excessively bend forward for 2 or more hours, right? There are solutions for it. Use a sawhorse workbench, readjust the ladders or reposition the body or take ergonomic breaks in between. Overhead work, working with elbows above shoulders for longer than 2 hours, that's gonna affect you a lot, right? So use lifts, use ladders, step ladders, use scaffolds, right? Use a push lift, anything. Then twisting torso while carrying a heavy load, always a problem. So position the load close to your body, right? And always turn by pivoting the feet rather than just your upper body. Then there is something called as contact stress. This is something I think a lot of safety professionals actually fail to think about. When you have workers bend down and working on their knees, right? We do not realize it, but they are actually putting a lot of stress on their patellas, their kneecaps, right? The cartilage that is present there, the nerves, the blood vessels, they do get crunched a lot. It's gonna hurt, right? So in this situation, we recommend that padding be provided, some sort, right? Some sort of simple padding be provided, but often forgotten about. Wrist deviations, working with the wrist bent or twisted for longer than 2 hours. See, we have got a range, right? We have got a range. You go beyond it, that's gonna cause a lot of trouble for us, right? So you want to move the working object closer to the body, use tools with bent handles. We'll talk about that a little while later. Take ergonomic breaks in between to allow for your body to relax. And lastly, vibration. Now, every safety professional knows about this. But not every worker is aware about this unless they have received the training for it, which is quite unfortunate because vibration do cause a lot of problems, right? Whether it is a whole body vibration or the hand arm vibration syndrome, right? So asking these workers, for example, in construction industry, to uh, choose awkward postures where they have contact stress or twisting their bodies, after a point, it is actually going to be quite stressful. So when you bend forward, your back muscles work hard and the ligaments flex. Uneven bending, for example, asking them to lift load, is the common reason why we have disc herniation, your slip disc. So some of the suggested control measure is the use of bend handles, correct? For example, everybody just look at the first image I have here. Looks like a sanded saw, right? Now you will think, okay, straight holding. You see the stress that is coming in this area, right? The stress. So rather having a straight handle would have given a lot more easier cut. A plier, let's say you have a nail that is present, I would like to remove it, and I'm using a plier for it. See again, the twist on my wrist. But however, a bent handle, I wouldn't have that same kind of effect. Even with a hammer, rather than using a straight hammer to do this hammering, look at the bent hammer that is there. Now you'll be saying, oh, that is just unnatural. But isn't all tools, right? So using these kind of tools can be quite helpful. In designing of PPEs, personal protective equipment, dear Lord, taking into account the dimensions of an individual has a significant impact on improving the safety and comfort of an individual. Where we take into consideration how to make the let's say you want to design a helmet. How will you do it? There's a whole process for it, the dimensional design, right? Calculation across the rims, at the top, the dome. Right? So these are going to design not just in helmets. Okay, I'm talking about a variety of things. For example, nanofibers are something that has become more popular nowadays when it comes to PPE design. Using of smart PPEs, you know, are something that is their integration of sensors into your personal protective equipment. The ability to customize and adapt your personal protective equipment is well, I could say the core essence of keeping a worker safe. Auto tinting or auto darkening helmet is a good example I can give you there. And the ergonomic design, form fitting gears. Let us say we are talking about a full face mask, EN 141 compliant, right? But without a form fitting rubberized seal, it's of no use. There will be gaps that is going to allow the gases and dust and other atmospheric threats to penetrate. And at the end of the day, usability and accessibility. We need these kind of HFE designed PPEs to be made available to the employees, so that they can do their work in the safest possible way. So what are some of the methods for improving this workplace ergonomics? See, first of all, we need to actually create an understanding among the non-safety professionals that yes, ergonomics is going to add value to the organization in various ways. What are the work-related musculoskeletal disorders are, and what are the work-related upper limb disorders are. Having these ergonomic designs is going to help your organization in the long run. The ergonomic evaluations, the program development, and the team ergonomics, training and mentoring can increase the rate at which a company creates completed products. For instance, in an office environment, look at what is happening there. The wrong seated position, this, the hunched over back, right? Despite the fact he has an ergonomically designed chair, there are so many people who actually do the work like that. Why? While you are supposed to do it in the either seated or standard position, procedure or position, as you can see on the screen. Now, how many of you can say with utmost confidence that you guys are always using the correct position for working? The basic do's and don'ts of manual handling actually is applicable here too. Lift as a team, never by yourself. Turn with the legs, never with your upward body. Do use your legs rather than your back, and do use equipment to make your jobs easier. For example, If you look to the screen, you can see some of the ergonomically designed tools and equipments that is presented. I already have shown you the auto adjustables I think table, right? This is the additional pad that can be purchased. Now, a lot of you will be complaining, I already have a keyboard, I cannot make it, it was expensive, I don't want to buy a new keyboard. Okay, fine. You can have additional attachments or supplements that can be brought. The padding for the keyboard or the mouse is actually available here for you to see. If you look here, you can see the way the keyboard is designed. Take into account the curvature of your fingers. If you look at the mouse, rather than having you to do the work like this, gives you a little bit more freedom when you have to do this, right? A different type of mouse. Food for thought. Yeah? Now, if you look at the pliers here, you see here, the same pliers that you use, but rather than having to do this for removal, you do a straight removal, you know? The ergonomic design cutters and other power tools you can see here. Even these, for example, these are called as stair climb trolleys and what's that, equipment for carrying materials up and down the stairs. It doesn't cost much, right? Let's say a standard trolley carrying, let's say 150 kilogram capacity costs 120 dirhams. You get the same thing, 120 dirhams for a stair climb trolley. Load handling equipment like these, whatever the shape or size, they can adjust. This is actually a product that I'm quite fond of. It's called as the Gorilla Gripper. Okay, it's a trademark name, but however, I would like to share it here. It's a product that is actually available in Amazon and such. Any material you want to lift up, a glass, let it be foam, let it be plywood, let it be gypsum boards, let it be metal sheets, pipelines, doesn't matter. If it's got a surface that you want to grip and you don't have a grip, this is your gripper. All you got to do is just clip it on and lift it up. That's it. You should check it out online. You will have some wonderful videos to watch, all right? And this is your buddy lifter, right? I saw this for the first time many years back when we called in a what's that, moving team to move my when I was shifting my houses. These guys came in with these belts. I did not understand what was going on. They just put this in. They just walked away with a huge refrigerator of mine. The one that took 4 people to actually get it delivered, the 2 guys took it out. It was like amazing to watch. These are all ergonomically designed tools, all part of the human factor engineering. Okay? So this is the concept I wanted to bring to you guys, to create an understanding that human factor engineering that is present there is not something that is new to you, but it's something that has always been present. It's all part of innovation to stay abreast with the changes that is happening around us, right? I'm happy to actually enlighten you about some of the new things, but I'm sure you might have actually seen majority of the other aspects I've actually brought forward, right? So this was my presentation. But before I finish off, I want to say a few words. Actually, any questions are there, please actually post it to the chat. We will take the questions in a short while. But before that, a quick word of thank you from my side. So finally, to IOSH and all the participants and the chair of the IOSH UAE, Mr. Syed, and Ms. Aparna Jayadevan, head of the QHSC Gulf Senior, who's the executive committee member of the UAE branch, and Ajay Prasad sir, who influenced me to actually deliver this. He's my mentor. I thank all of you guys for actually giving me this opportunity to deliver the session. So, Mr. Syed, I hope
Thank you
you'll
very
take
much,
over.
Mr. Vivek.
Thank you,
Indeed,
Mr.
it
Asir.
was a very good and comprehensive presentation. We have a couple of questions. The first question is like, what are the key challenges or obstacles faced when implementing human factor engineering, and how can they be overcome?
Okay, human factor engineering is a concept that many people are unaware of. I think that would be your greatest challenge that is present there. Convincing an organization to actually implement human factor engineering can be quite difficult because the benefits that it brings is quite subtle, just like safety. It is not an immediate change that you will see, but however, in the long term, the drastic increase in productivity it will bring to your organization will be quite large. Obviously, it will be quite advantageous for us if you could have your management and others take a leap of faith. But ideally, to convince your management and to overcome this obstacle, you can say couple of things that can be done is actually introducing them or enlightening them about the case studies such as the ones I actually shared with you, to show how it helped those organizations actually improve their performance and productivity. Another barrier I think that will be present is well, we are in UAE, we have a eclectic bunch of people that is present here. And when you're implementing human factor engineering, you need to understand, because of the variety of people there and the dimensions that vary from person to person, right? For example, let's say somebody who's from, I'm saying on average, okay, I'm not saying everybody's the same. Let us say we have people from certain parts of the world tend to have a higher stature compared to certain countries where the people have a lower stature on average, right? So when we have, let's say, a group of 20 people who's working together, and we want to actually implement, we want to design something using human factor engineering, that can be quite difficult. So in that situation, what I can actually suggest for you guys is to actually look at human factor engineering in such a way that it is an adaptable, or you can say adjustable control measure, like the standing chair that I actually, standing table that I actually showed you guys. That is another obstacle that can be overcome with a little bit of innovation and intuitiveness. These are the two major ones that actually comes to your mind. Right? Anything
Thank you
else, Mr.
very much.
Asif? Please.
We have one more question. How can companies measure the impact and effectiveness of human factor engineering initiatives?
Very well. The impact of implementing human factor engineering can be actually measured in various levels. Number one, you can actually see that in the type of injuries or type of, you can say, difficulties that is actually reported by the various employees of an organization, right? Over the time, you can actually see a trend analysis. The people who, they are, depending upon the duration that they are working in doing a particular activity and the type of illnesses or complaints that are actually put forward with their physical body, or their, what's that, psychological, that is present there, right? And now using this, you can, one trend analysis, you can say, okay, how much is the impact of lack of HFE impacting? And once you implement the control measure, you can see how much is the drastic change that is present there. You can also measure it in terms of productivity. You may have certain equipments that is installed in, or certain machineries or certain plants that is installed in your organization, and despite your what's that, manufacturer or the supplier of the equipments attesting to a higher productivity, you may not be able to achieve it. But with a little bit of HFE implemented in your organization, you will be able to again see a drastic change. These are some of the ways, in the terms of your outputs and in terms of reduction in injuries, you can measure the impact of human factor engineering in your organization.
Thank you very much. One more question. How is the language barrier affecting the human factor engineering, as many equipment produced globally and human intervention required common language?
Right. Actually, it is not rather language, but rather the regional barrier that I was talking about. Let us say, for instance, we have, let me give you a few instances, okay? For example, some of the tallest people that is present in the world, right? If you look at the average height of people from, let's say, Germany, Russia, certain parts of Africa that is present there, we're very tall, right? You will say approaching 6 foot. But if you go to certain parts of the world where you will see extremely people of extremely short stature too, right? For example, let's say the pygmy tribes of Africa, they have extremely short stature, right? The average height is close to about 4 to 5 feet only, right? So if we were to actually design equipments for these people, obviously that is the bigger barrier, I would say. But yes, language do play a factor, because for you to actually implement any engineering control measure, human factor engineering measure that is there, you need whoever is actually obtaining or benefiting from the control measure to understand the benefit and implementing these measures in the right way, right? So that is obviously a barrier that is present there, which is why more often than not, when we use human factor engineering, we try to incorporate multiple languages, including pictographic implementations, where, for example, if you look at the ergonomically designed tools, a lot of them do not have written instructions nowadays. Most of them have the symbols that shows, okay, what to do and how to do it. For example, we recently purchased a new printer for my department, actually. I was actually quite surprised, because the previous printer had a lot of written instructions there. This is ergonomically designed, and every single thing, for example, how to open, how to close, how to remove something, nothing is written down. They have actual diagrams that is actually shown there, and which very clearly shows how to utilize it without actually putting myself in any danger, without straining myself in any way. So yes, there can be ways to overcome even the language barrier. Best is pictographic, but other is to have multiple languages implemented if that is not feasible. Anything else, Mr. Asif?
Thank you very much. That's it from my side. Mr. Saeed, the floor is yours. Thank you.
Thank you very much, Vivek. It was very informative. You brought something which is day-to-day stuffs for all health and safety professional, and apart from this, the other non-HSE professionals will also require such kind of information. Thank you very much to all the attendees. We have touched approximately 150 attendees in the session. The session was going very good. We didn't lose any of the single attendees, so I think it was very interesting and to the point, and you really did a tremendous job on this, because you took our advice to do it within the time frame, and that's why we're having all of these attendees still with us. Thank you very much, guys. IOSH UAE branch is always eager to bring you good stuff. You have the opportunity to be a speaker. Please approach us through uae@ioshnetworks.com or approach us through our LinkedIn, or approach one of the members or to me directly, and we will give you the opportunity definitely. There will be a post survey, I believe. We need you to please fill that survey. With regards to your certification, whosoever attended the minimum 35 minutes, they will get the certificate in 3 weeks. The presentation will be available and the video will be available under the IOSH UAE branch webpage. With that thoughts, let's stay blessed and be happy. Thank you very much for your time. Signing off, Sayyid Mazhar from the UAE branch. Bye-bye. Take care.
Thank you, everybody. Thank you once more. Have a very good day. Goodbye.